Autoflight pitch modes control climbs, en route cruise, descents, and supply vertical guidance and commands for approaches and automatic landings. The Autoflight system pitch modes are shown here. Toga, GS, and flare are discussed in a different lesson. You select pitch modes with these switches on the MCP. You control the pitch modes with the MCP and with the CDU. When FCCA is the master FCC, the Autoflight system uses data from the captain's barometric altimeter. When FCCB is the master, the first officer's altimeter is used. The flight mode enunciation shows autothrottle status and pitch mode. Autoflight pitch modes automatically engage an autothrottle mode if the autothrottle is armed. The N1 autothrottle mode tells the autothrottle to set thrust at the active N1 limit and keep it there. Speed is controlled by changes in the airplane's pitch. The FMC normally supplies the autothrottle with the N1 limit. Here, auto is active and the FMC automatically sets the N1 limit for the related phase of flight. When MCP speed shows in the autothrottle status field, the autothrottle controls the thrust to hold the speed set in the IAS Mach display window. When MCP speed shows in the pitch mode field, the autopilot controls pitch to maintain the set speed. Retard shows when the autothrottle reduces thrust to idle. When the thrust is at idle, the retard enunciation is replaced with arm. Arm tells you the autothrottle is armed, but it does not control thrust. When arm is shown, you can move the thrust levers as if the autothrottle was disengaged. If you manually move the thrust levers when the autothrottle mode is N1 or retard, the autothrottle returns to the target thrust when you release the levers. You can find yourself in a fight with the autothrottle. Above flight level 260, the IAS Mach display automatically changes to a Mach number in the window. Below flight level 260, the speed is usually in knots. Push the changeover switch to change the IAS Mach display window from Mach to knots. The MCP speed is now in knots. The Autoflight system pitch modes level off the airplane at the altitude set on the MCP. When VNAV is the pitch mode, the airplane usually levels off at the FMC altitude. But if the MCP altitude is between the airplane and the FMC altitude, the airplane stops at the MCP altitude. The Autoflight system also alerts pilots to level-offs and altitude deviations. In this example, the airplane is in a descent to a new MCP altitude. When the airplane is near the MCP altitude, you hear the altitude alert tone, see a box around the current altitude, and see an altitude alert box above each altimeter. When the airplane is near the MCP altitude, the altitude alert boxes extinguish. As the airplane levels off, the FMA changes to altitude hold. The altitude alert operates the same in climb. In level flight at the MCP altitude, if you climb or descend too much, you will hear the altitude alert tone. The current altitude box changes color to amber and starts to flash. The current altitude box flashes until the altitude error is corrected. Or until the error is more than the alert limit. Or until a new altitude is set in the MCP altitude display. If an autopilot is engaged in command, but no pitch mode is engaged, the autopilot uses the default mode CWS pitch. To change the default condition, you must select a pitch mode. Push altitude hold to engage a pitch mode. The default pitch mode is replaced by altitude hold. You use the level change mode to climb or descend to the altitude set in the altitude display window. In a level change climb, the autothrottle uses the maximum thrust. Thrust is set to the active N1 limit, and N1 shows in the autothrottle field of the FMA. In a level change descent, the autothrottle uses the minimum thrust. Because it uses the active N1 limit thrust or idle thrust, level change is best used for large altitude changes. In this example, ATC clears you to climb to flight level 350. First, set the new target altitude. Push the level change switch to engage level change. The airplane climbs to the new MCP altitude. The autothrottle status field of the FMA shows N1, and the pitch mode field shows MCP speed. When the airplane reaches flight level 350, it automatically levels off. The altitude acquire and altitude hold modes are discussed later. The vertical speed mode also changes the airplane's altitude to the altitude set in the MCP altitude window. With the vertical speed mode, you set the rate of vertical change with the vertical speed thumb wheel and display. The vertical speed mode usually causes small changes to thrust and the airplane's pitch attitude. Because of these small changes, the vertical speed mode is best used for small altitude changes. You can engage vertical speed in two ways. If the airplane is in altitude hold, set the MCP altitude display window to a new altitude. Set a new MCP altitude of 8,000 feet. VS in small white letters tells you that the vertical speed mode is armed. To engage the mode, you select a target vertical speed with the vertical speed thumb wheel. Set a vertical speed of -500 feet per minute. The large green letters on the FMA show that vertical speed is engaged. The short magenta lines on the vertical speed indicator show the selected vertical speed. The vertical speed mode automatically engages MCP speed for the autothrottle. In this example, MCP speed was engaged while the Autoflight system was in altitude hold, so there was no change in the autothrottle mode. You can use the vertical speed thumb wheel to set the vertical speed for a climb or descent. Move the thumb wheel down to set a positive vertical speed and climb. An arrow and label show the correct direction to move the thumb wheel. To descend, move the thumb wheel up to set a negative vertical speed. If you want to descend but accidentally set a positive vertical speed, the airplane climbs. Because the airplane moves away from the MCP altitude, there is no automatic level off. If you are already in a climb or descent, you can push the vertical speed switch to engage vertical speed. The airplane's vertical speed shows on the MCP. The pitch field of the FMA shows vertical speed engaged. To change the vertical speed, move the thumb wheel. Set a vertical speed of plus 500 feet per minute. The climb continues at 500 feet per minute. The Autoflight system uses altitude acquire and altitude hold to automatically level off the airplane. The airplane starts to level off before the MCP altitude. Altitude acquire replaces vertical speed as the pitch mode annunciation. The point at which altitude acquire engages is calculated from the climb rate of the airplane. When the level off is complete, altitude hold replaces altitude acquire. When altitude acquire or altitude hold engage as pitch modes and the autothrottle is armed, the autothrottle engages in MCP speed. Automatic level-offs after descent are the same. You can also use the altitude hold switch to stop a climb or descent. If you engage altitude hold when the airplane is at an altitude other than the MCP altitude, the airplane levels off at the altitude where the altitude hold switch was pushed. The level off does not occur immediately. The airplane momentarily descends below the altitude in a level off from a descent, and momentarily climbs above the altitude in a level off from a climb. In this example, the airplane is in a descent to 16,000 feet. Use the altitude hold switch to stop the descent. The altitude hold switch was pushed at 17,400 feet. The airplane descends below 17,400 feet during the level off, but comes back to the altitude where altitude hold was pushed. Altitude hold replaces the VNAV path annunciation in the pitch field of the FMA. The autothrottle status field is now MCP speed. After altitude hold engages, the AFDS holds the uncorrected barometric altitude the airplane was at when the mode engaged. Later changes in altimeter barometric setting do not make the airplane climb or descend to follow the new indicated altitudes. When VNAV engages, the FMC commands pitch and autothrottle modes to fly the vertical path shown on the CDUs. The profile includes climb, cruise, descent, and speeds. It can also include waypoint altitude constraints. To use VNAV, the Autoflight system must have an FMC path to follow. VNAV speed holds the FMC target speed. This speed is shown by the airspeed cursor and on the CDU climb or descent pages. VNAV path uses pitch commands to follow the FMC altitude or descent path. If the airplane climbs in VNAV, the autothrottle sets the FMC supplied climb thrust. The autopilot maintains the FMC airspeed with pitch. Notice the MCP IAS Mach display. Because the FMC controls the target speed, this window is blank. In cruise, the autothrottle maintains the FMC target speed and the autopilot maintains the FMC altitude. If you select a lower MCP altitude, the AFDS arms to automatically start descent when the airplane reaches the top of descent waypoint. In a VNAV speed descent, the autothrottle sets the thrust to idle and the autopilot holds the FMC target speed. In a VNAV path descent, the autopilot commands the airplane to follow the FMC vertical path. The autothrottle holds idle but can command the FMC speed mode if ground speed is too slow to follow the FMC vertical path. In this example, the FMC route has a cruise altitude of flight level 350. ATC tells you to climb and maintain 15,000 feet. Set 15,000 in the altitude window. Push the altitude intervention switch. The FMA shows you that VNAV speed is engaged as the pitch mode and that N1 is the autothrottle mode. At 15,000 feet, the airplane levels off because you captured an MCP altitude. ATC now clears you to flight level 350. Set the new MCP altitude and push the altitude intervention switch. The airplane again climbs in VNAV speed. At flight level 350, the airplane again levels off. The FMA changes to FMC speed and VNAV path. The airplane can automatically follow the descent path if you have set the MCP to a lower altitude before you pass the top of descent. To help you, the CDU scratchpad message Reset MCP Altitude is shown. Set a lower altitude on the MCP. The airplane descends in VNAV path. The autothrottle sets the thrust to idle. If the winds change the ground speed until it is too slow to follow the FMC path, the autothrottle adds thrust to follow the descent path. If winds change the ground speed until it is too fast to follow the FMC path, the Autoflight system pitches down to follow the path. And the CDU scratchpad shows the message Drag Required if the airspeed increases to more than 10 knots above the FMC target speed. If ATC tells you to change airspeed during VNAV flight, it can be difficult to do so quickly. In VNAV modes, the speed targets come from the FMC, the IAS Mach window is blank, and you cannot change the speed with the MCP. To quickly change speeds, engage a different pitch mode and use the MCP speed selector to set the new target speed. For level flight VNAV legs, engage altitude hold. When altitude hold engages, the IAS Mach window changes from blank to the current speed. Set the new target speed. For VNAV climbs or descents, engage vertical speed or level change and set the new speed. You can also make airspeed changes in VNAV flight with speed intervention. Speed intervention is discussed in another lesson. When the airplane flies in VNAV, the Autoflight system will obey speed and altitude constraints attached to the flight plan waypoints. This is a powerful feature of VNAV and can make arrivals and departures easier to navigate. But if ATC asks you to delete an altitude constraint or change an airspeed, it can mean that you have to program the FMC when you should be looking for traffic. You can use speed and altitude intervention to make these changes. Speed and altitude intervention work only when VNAV is engaged. In VNAV, the MCP IAS Mach display is blank, and you cannot change the speed with the MCP speed selector. When you push the speed intervention switch, The IAS Mach display window will open to the current FMC target speed. The target airspeed line of the CDU shows that the MCP controls the speed. You can now change the speed using the MCP speed selector. The target speed is now 0.78 Mach. If you push speed intervention again, the IAS Mach window blanks and control of the target speed returns to the FMC. You are flying the KLAX loop departure. The FMC shows altitude constraints at kegs and coupe. The altitude constraint of 13,000 feet for kegs is in the MCP altitude window. ATC tells you that the constraint at kegs is deleted. Because there is still a constraint at coupe, enter 15,000 feet into the MCP altitude window. When you push altitude intervention, the constraint at kegs erases. The airplane levels at 15,000 feet to obey the FMC altitude constraint at coupe. ATC now clears you to your planned cruise altitude of flight level 350. If the airplane is at an FMC altitude constraint, altitude intervention lets the airplane resume the VNAV climb. Here the climb will continue to the flight level 350 cruise altitude. ATC clears you to a new cruise altitude of flight level 390. Set the MCP altitude to 39,000 and push altitude intervention. Set 39,000. Continue. If the MCP altitude is above the FMC cruise altitude, the FMC cruise altitude increases to the higher MCP altitude. Here you are in a VNAV path cruise. ATC now clears you to flight level 410. Set 41,000 in the MCP altitude window and continue. The FMC cruise altitude changes to match the MCP, and the airplane begins a cruise climb to flight level 410. If you set the MCP altitude below the current FMC cruise altitude and push altitude intervention, the airplane begins an early descent. You cannot set a lower cruise altitude with altitude intervention. Continue. In this example, the airplane flies the red-eye arrival to KLAX. There are many altitude constraints on this arrival. In the descent to Civet, the MCP altitude window shows 14,000. ATC removes the altitude constraint at Civet. Set the next lower altitude constraint and push altitude intervention. Since the altitude restriction at Bindi is at or above 12,000 feet, set 12,000 in the MCP altitude window. Continue. The constraint at Civet erases. ATC now removes the constraints at Bindi, Bassett, and Downey. Use altitude intervention to remove the constraints. Continue. Set the MCP altitude window to cross Santa Monica at 8,000 feet. Continue. 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 If all altitude constraints are removed from a VNAV path descent, the FMC automatically changes to a VNAV speed descent. ATC clears you to 6,000 feet and removes the altitude constraint at Santa Monica. Set 6,000 feet in the MCP altitude window. Continue. You are 5 miles behind slower traffic. ATC tells you to slow to 250 knots for separation. Use the AFDS to slow the airplane. You are in level flight at 9,000 feet. Autopilot A is engaged, but no pitch mode is selected. Engage an AFDS pitch mode. ATC has cleared you to descend and maintain 8,500 feet. Use the AFDS to descend. Operate the thumb wheel to engage the vertical speed mode. You are in a descent to 8,000 feet when ATC tells you to hold your present altitude. Use the AFDS to stop your descent. The airplane levels off at 8,600 feet. Reset the MCP to stop the altitude alert. Use the altitude selector to set the altitude display to 8,600 feet. ATC clears you to descend to 10,000 feet. Use the level change mode. ATC tells you to reduce your descent rate to 500 feet per minute. Use the AFDS to set a 500 feet per minute descent. Push the vertical speed switch on the MCP. ATC clears you to descend to 8,000 feet. Use the vertical speed mode to descend. Use the thumb wheel to set the descent rate. ATC tells you to maintain your altitude for traffic. Use the AFDS to level off immediately. The FMC has a route with a cruise altitude of flight level 330. ATC clears you to climb to flight level 330. Use VNAV to climb to the cruise altitude. Push the VNAV switch on the MCP. You are in VNAV cruise flight, and ATC tells you to slow to 0.72 Mach for separation. Use speed intervention to slow the airplane. Push the speed intervention switch on the MCP. You are in VNAV cruise flight, and ATC clears you to climb to flight level 370. Use altitude intervention to change the cruise altitude. Set 37,000 feet in the altitude window on the MCP. You are on the SATI arrival to KLAX when ATC tells you to descend to 10,000 feet and delete the altitude constraint at Simon. Use altitude intervention to remove the constraint. Set 10,000 feet in the altitude window on the MCP.